Today's notes are on chemical bonding. Some of this might be new information for you, and some of it you might have learned before. Either way, this is important because remember that chemistry is important in biology. And if you plan on taking chemistry later on, these things will come back. So it is September 9th, 9/9, and these notes are on chemical bonding. First, a review from yesterday. Atoms are made of three parts: protons, neutrons, and electrons. The protons and neutrons are in the middle of the atom, and the electrons are around the outside. Atoms can bond together using their electrons. In this picture, those two electrons that are inside the box, those are the ones that are being used for a bond. That's what we're talking about when we talk about chemical bonding. We're looking at how are the electrons bonded so that these two atoms can come together. Now here's a periodic table. When you look at bonding, it's important to know what kinds of atoms you are putting together, because that will give you a clue as to what kind of bond you have. On this periodic table, the ones that are in silver are metals, blue are metalloids, and yellow are nonmetals. Metalloids are the strange group that are somewhere between a metal and a nonmetal. We're not really going to look at metalloids today. We're going to mostly focus on metals and nonmetals. This periodic table will be helpful to you in a second because you're going to need to know which atoms are metals and which ones are nonmetals. Here are three types of bonds you need to know for biology. The first one is a covalent bond. In a covalent bond, the atoms are equally sharing the electrons. In an ionic bond, one atom steals the electrons from the other atom. And there's a third kind of bond that's called a hydrogen bond. It is very weak. Covalent and ionic are pretty strong bonds. Hydrogen bonds are very weak, and they only form between hydrogen and some other atom. Before you start writing all of this, I'm going to leave some space between each one because we're about to talk about them individually. So whenever you go to write down these definitions, leave yourself a few lines in between so you can write more. For a covalent bond, we just said that atoms share electrons. So for example, over here we have a carbon atom and 4 hydrogens. They are equally sharing those electrons. Here we have 2 oxygen atoms. They are equally sharing these electrons. So nobody has the electrons more than anybody else. It's a nice even bond. Covalent bonds form between non-metals. If we scroll back up to that periodic table real fast, a covalent bond would form between any two in yellow. Ionic bonds. They form between one metal and one non-metal. The one you see in the picture here is sodium and chlorine. Sodium chloride is salt, table salt. But if we look back at our periodic table, here's sodium, it's a metal, and way over here is chlorine, it's a non-metal. So when sodium and chlorine come together, that is a metal and a non-metal. It's an ionic bond. something kind of crazy happens in ionic bonds. The non-metal steals electrons from the metal. It's not a nice even bond like a covalent bond might be. In an ionic bond, the non-metal is stripping that electron right off of that poor metal. Now for a hydrogen bond. These ones are weird. They're not like a covalent or an ionic. If you were to take a covalent or an ionic bond, they're pretty strong bonds. They're hard to break. A hydrogen bond is different because it's very weak. It's sort of just like a temporary attraction. One way to remember it is that covalent and ionic bonds are like two people being married. They're put together. Whereas hydrogen bonds are kind of like a date, a one night kind of thing. It's going to be temporary, it'll be over soon. This is very important with water. Hydrogen bonds will come back in a few days when we talk about water, because a lot of the great things that water does for living things, that couldn't happen if water couldn't form hydrogen bonds. When we draw a bond, we show the atoms in their symbol form. So on the periodic table, there's the symbols. You use the symbol, just this letter or two letters, and you draw a line between them to show where the bond is happening. On the left there we have water, H2O. On the right you've got carbon dioxide. Now carbon dioxide looks a little bit different than water, and that's because right here when you have a double line, that means that they're actually bonding to each other twice. So carbon and oxygen here have two bonds, carbon and oxygen here have two bonds. Whereas over here in the water molecule, you just have one bond between oxygen and hydrogen, and just one bond here too. It's kind of difficult for me to draw these pictures in the Microsoft Word, but it would be a good idea in your notes to pause the video now and draw one of these. That way you have a picture in your notes of what these atoms should look like when they're bonded. That is the end of the notes for today. Please remember to write down any questions you might have so that you can ask them later.